Dear students, in the last lecture we started the properties of eigenvalues and we have seen so many properties of eigenvalues. Now let us continue our topic, that is what? Properties of eigenvalues. Properties of eigenvalues. Eigenvalues, and we will see so many properties of eigenvalue. Okay, and we continue. The next property is what? Number one, if lambda is an eigenvalue of is an eigenvalue of the matrix, if lambda is the eigenvalue of the matrix A, then f of lambda is an eigenvalue of the matrix f of A, where f of x is any polynomial in x. Okay, now the next property is number two, if lambda is an eigenvalue of the matrix A, then determinant of A by lambda is the eigenvalue of adjoint of the matrix A. Okay, if lambda is the eigenvalue of the matrix A, then determinant of A by lambda is the eigenvalue of adjoint of the matrix A. This is the second property, and first one is says that if lambda is eigenvalue of the matrix A, then f of A is the eigenvalue of the matrix f of A, where f of x is the polynomial in x. Okay, you can write here, where f of x is any polynomial, any polynomial. Okay, so let us do some problem based on this, then you will understand what are the properties of eigenvalues. Okay, so we write down the example. Let A be the given matrix. Your matrix is given to you, that is 1 0 0 and -3 2 -3 2 0 6 6 1 and 3. This matrix is given to you. Okay, then find the following. Find the eigenvalues of the matrix A, and hence number one, find the eigenvalues of find the eigenvalues of A raised to 20. Number two, find the eigenvalues of A inverse. Number three, find the eigenvalues of 15A. Okay, next, fourth one, find the eigenvalues of eigen values of adjoint of A. Okay, and next fifth one, find the eigenvalues of eigen values of the matrix 3A inverse plus plus 4A 4A square and plus 20A. Okay, and we have to find out the eigenvalues of this. So what I have to do first? We have to determine the eigenvalue of the matrix A. Then we will find the eigenvalues of these five. Okay. Solution. Let us start the solution. So first of all, what I have to write down? We just write down given matrix. Given matrix A is equal to what? A is equal to 1 0 0 minus 3 2 0 and what is this? This is 6, huh? Not minus 6. This is 6 and 6 1 and 3. Okay, this matrix is given to you, and what I have to do, I have to find out the eigenvalues. Okay, we first find the determinant of this matrix. What is the determinant? What is the determinant of this matrix? Just write down 1 0 0 minus 3 2 0, then 6 1 3. Okay, just find out determinant of this matrix, and this is equal to what? 1 and cross multiply 3 to the 6 and 0. So 6 minus 0 and minus 0. This one cross multiply 3 3 is 9. So minus 9
तो पूरा
minus.
जीरो हो जाएगा ना,
Ha,
जीरो से
the
मल्टीप्लाई
whole
होगा।
thing will be 0. There will be 0. Okay, minus 9 and this will 0 and plus 0. So this is what? Minus 3 and minus 6 to the 12 means this will 0. So you will get only what? 6. Okay, your determinant is 6. Now find out trace of this matrix. So trace of this matrix is equal to what? Sum of just diagonal element 1 plus 2 plus 3, that is how much? 3 to 5 plus 1 6.
सिक्स।
Trace, yes, trace is 6 and determinant is 6. Now what I have to do? We have to find out the its characteristic polynomial or characteristic equation. So we first find characteristic equation. So since we know that a minus lambda I is equal to 0, this is formula for your characteristic equation. Okay, so what I have to do? Just write down here. This become 1 minus lambda. And what about other element? Other element is 0. And the second element is what? Minus 3. So just write down minus 3, then 2 minus lambda. Lambda will be subtracted only from diagonal element. Okay, and the next element is what? 0. So just write down 0 and here 6 1, write down 6 as it is and 1 as it is. Then last element is what? 3. So there will be 3 minus lambda, 3 minus lambda. Okay, and this equal to 0. Now just find out determinant of this matrix. Okay, what are the determinant of this matrix? So we have 1 minus lambda. Okay, 1 minus lambda and multiply this. So this will what? 2 minus lambda into 3 minus lambda, and this will what? 0, and here 0 multiply. So this is minus 0. This element, that is 0. So it's equal to what? 0. So you will get 1 minus lambda and 2 minus lambda, 3 minus lambda, in all these things will be 0. This is 0 and here plus 0, and this is equal to what? 0. So 1 minus lambda and 2 minus lambda, 3 minus lambda, and this is equal to 0. So we have 1 minus lambda equal to 0, or 2 minus lambda is equal to 0, or you can say 3 minus lambda equal to 0. So from this you will get lambda equal to what? 1, and here lambda equal to what? Lambda equal to 2, or lambda equal to 3. So therefore lambda is equal to 1 comma 2 comma 3 are the are eigenvalues of eigenvalues of the matrix A, of the matrix A. Okay, so this is the first step. Now what? Now our job is what? Our job is to determine the eigenvalues of A raised to 20, A inverse, eigenvalue of 15A, eigenvalue of adjoint of A, and eigenvalue of this equation, that is 3A inverse plus 4 times of A square plus 20A. Okay, so let us see how to find the eigenvalue of A raised to 20. Okay, number one. Now to find to find eigenvalue of eigenvalues of A raised to 20. Okay, so here you will write since since lambda is eigenvalue of A, since lambda is an eigen eigenvalues of matrix A, so this implies that lambda raised to n is the eigenvalue of what? Is the eigenvalue of A raised to n. Okay, so just replace this. So therefore eigenvalues of A raised to 20 are what? Therefore eigenvalues of A raised to 20 are, first one is what? First one is 1 raised to 20, okay, comma 2 raised to 20, and 3 raised to 20. Okay, so eigenvalues of the matrix A raised to 20 are this one. Okay, if lambda is eigenvalue of A, then lambda to the power n is the eigenvalue of A raised to n. So these are the lambda. So उसके power how much? So इसके power आपको 20 करना है. So you will get the eigenvalue of A raised to 20. Okay, this is for first one. Number two. Number two is what? Number two, find the eigenvalue of A inverse. Okay. Now to find eigenvalue of A inverse. To find eigenvalue of eigenvalues of A inverse. Okay. Now again we have, since lambda is eigenvalue of lambda is an eigenvalue of lambda is eigenvalue of A, then 1 by lambda is an eigenvalue of, therefore we
1 by 2 and 1 by 3.
1 by 2 and 1 by 3 are eigenvalues of A inverse. Okay, 1 by 2 and 1 by 3 are the eigenvalues of A inverse. Now the next part is what?
Sir,
Next one is to find eigenvalues of 15A. To find eigenvalue of 15A. Let us move to the next page. Number 3.
15, 30, and 45.
Yes, yes. To find eigenvalues of 15A. Okay, so since lambda is eigenvalue of eigenvalue of A, then Ka Ka is is an eigenvalue of eigenvalue of sorry A lambda, then K lambda is eigenvalue of A. Okay, so therefore 15 1 comma 15 2 and 15 3 are eigenvalues of eigenvalues of 15A. ठीक है, that is 15 30 and 45 are eigenvalues of matrix 15A. Okay, getting? Now similarly you can find the next one. Find eigenvalues of adjoint of A. This part is number 4. To find eigenvalues of values of adjoint of the matrix A. Okay, again we write here, since lambda is eigenvalue of A, lambda is an eigenvalues of A, then determinant of A by lambda is an eigenvalue of eigenvalue of adjoint of matrix A. Okay, so therefore determinant of A is what? How much we found determinant? Determinant is 6. Okay, so therefore 6 by lambda is what? 1 comma 6 by 2 and 6 by 3 are eigenvalues of the matrix adjoint of A. That is what? That is 6. 6, 2 3 ja 6 and 3 2 ja 6 are eigenvalues of the matrix adjoint of A. Okay, and number fifth, to find eigenvalues of the matrix 3A A inverse plus 3A inverse 3A inverse plus 4A square plus 20A plus 4A square plus 20A. Okay, we have to find out eigenvalues of this equation. Okay, again we write, since since 1 comma 2 and 3 are eigenvalues of the matrix A, eigenvalues of the matrix A. Therefore फर्स्ट वन के लिए लिख रहा हूं मैं, therefore three 1 inverse, okay, 3 1 inverse plus 4 plus 4 1 square and plus 21 comma then 3 into 2 inverse 2 inverse plus 4 into 2 square and plus 20 into 2 and next one is what 3 into 3 inverse 3 into 3 inverse plus 4 into 3 square and plus 20 into 3 are eigenvalues of the matrix A inverse plus 4A square plus 20A. Okay, so just simplify that is सिंपलीफाई करो यहाँ पे 3 मिलेगा 3 plus 4 7 और 20 how much 27 and here just find out the expression so 3 by 2 3 by 2 and 4 cancel plus 1 3 by 2 plus 1 and plus 40 40 and 3 and 3 cancel that is 1 plus 3 3 is 9 into 4 36 and plus 3 to the 6 that is 60 okay are eigenvalues of यहाँ पे देखिए यहाँ पे yes yes 2 to the
Yes, sir.
4 and
Yes.
4 for the 16 होगा
4 plus 16. Yes, sir.
16 ना so this is 3 2 and 4 into 4 16 and plus 20 are eigenvalues of
So वो 3/2 आएगा 3/2 16 plus 60.
हाँ just cross multiply are eigenvalues of eigenvalues of 3a inverse plus 4a square plus 20a okay जस्ट इसको क्रॉस मल्टीप्लाई करके इसको निकालो हाउ मच दिस बट हाउ मच दिस इज 56 मल्टीप्लाई बाय 2 plus 3 हाउ मच
112/2
सो
112/2 तो हो गया आपका 115/2.
27 मल्टीप्लाई करो 56
That's 57.5.
नहीं पॉइंट में नहीं लिखो फ्रैक्शन में बताओ
सर वो
So
115
वही
बटे 2.
so फिर 115/2 आएगा.
115 बटे 2.
100/2 ओके एंड दिस वन
इसे बता रहा हूँ.
सर वो आएगा आपका 104
97 सर 97.
97
हाँ
Yes.
97.
okay so these are the eigenvalues of the given equation that is what 97 are eigenvalue of 3a inverse plus 4a square plus 20a okay I hope you understood how to find the eigenvalues of the given matrix okay by using properties of eigenvalues you understood this how to find first of all what have to do first we have to find the eigenvalue of the given matrix then apply the properties of eigenvalue okay yes or no you got it
Yes, sir.
हाँ very simple आसान था ये सब let us move to the next page okay now some important result okay some important properties of eigenvalues important some important result on eigenvalues result on eigenvalues. Okay, so first one is what? Eigenvalues of real symmetric matrix are eigenvalues of values of a real symmetric matrix are all real. Okay, so if any symmetric matrix is given, the eigenvalue of that matrix is a real number. Okay, number two, eigenvalues of eigenvalues of a real skew symmetric matrix, real skew symmetric symmetric matrix are eigenvalues of skew symmetric matrix. Real skew symmetric matrix are purely imaginary number or it will zero. Okay, number three, eigenvalues of Hermitian matrix, eigenvalues of eigenvalues of Hermitian matrix are eigenvalues of Hermitian matrix are real are real. Okay, number four, eigenvalues of skew Hermitian skew Hermitian matrix are skew Hermitian matrix are either purely imaginary or zero. Purely imaginary number or it will zero. Okay, and the fifth property is what? The fourth property says that eigenvalue of skew Hermitian matrix are either purely imaginary or zero. And the next property is what? Eigenvalue of unitary matrix are unit modulus. Eigenvalues of or unitary matrix are of unit modulus, or you can say that its eigenvalue have absolute value 1. Okay, both are same. The next result, eigenvalue of an orthogonal matrix are sixth one, eigenvalues of an orthogonal matrix are of unit modulus are of unit modulus. So eigenvalues of unitary matrix and orthogonal matrix both are same. Here eigenvalues of real symmetric matrix and Hermitian matrix are same. And here eigenvalues of skew symmetric matrix and skew Hermitian matrix are same. Getting? So these are the important result of eigenvalue you must have to remember for your objective questions. Getting? So no proof is required for this statement. Okay, you got it? Your next topic is eigenvector. So let us define eigenvector. Eigenvector. Okay, and what is the eigenvector of the matrix? So here let A be n cross n matrix. Okay, let A be an n cross n matrix, comma lambda be n scalar, lambda be in scalar, and I be or unit matrix. I be unit matrix of same order, unit matrix of the same order of matrix A, unit matrix of the same order matrix A. Okay, then there exist a non-zero column matrix, a non-zero column matrix X such that AX equal to what? Lambda X. AX equal to lambda X. That is, if I simplify this, that is AX equal to lambda X. So we shifting this on that side. So this is what? AX minus lambda X, and this equal to what? 0. And if I further simplify, this become A minus lambda I. I is what? Unit matrix. Okay, I is unit matrix into X equal to 0. So this is your formula for eigenvector. Okay, so where X is called an eigenvector. X is called an eigenvector corresponding to eigenvalue, corresponding to the eigenvalue lambda. Okay, so your X is what? X is your eigenvector, and it is given by, and it is given by x1 is equal to what? Write down the column matrix x1, x2 up to what? Xn. Okay, this is your column vector. So what is the order of this? This is how many rows? 1, 2, 3 up to n rows. And how many column? 1 column. ठीक है?
one column.
Yes. और इसको ऐसा भी लिख सकते हो, इसको ऐसा लिख सकते हो x1, x2
So one row and n column.
xn transpose like this. Okay, इसको आप इस फॉर्म में भी लिख सकते हो, वेक्टर फॉर्म में भी. So x is called what? Your x is your eigen vector corresponding to the your eigen value. Okay, यहाँ पे मैं लैम्बडा लिखा हूँ तो यहाँ पे केवल x ही लिखूंगा. ठीक है, so this is x is known as what? Eigen vector corresponding to eigen value lambda. Getting? You understood definition? What is the definition? If any square matrix is given to you and lambda is any scalar and I is the unit matrix, then there must exist a non-zero column matrix X such that this condition hold. And if I simplify this, so you will obtain the formula for eigen vector A minus lambda I into X equal to 0. Okay, you must remember this formula while doing the problem. Now let us do the problem based on this, then you will understand the definition properly. Okay, so let us take one of the simplest example. So let us move to the next page. The example, write down example. Find the eigenvalue and eigenvector of the matrix. Find the eigenvalues and eigenvector eigenvectors of the matrix is given to you. A is equal to, write down the matrix, 1 2 1 2 4 3. This matrix is given to you, and what have to do, have to find out the eigenvalue and eigenvector of this matrix. Okay, let us see the solution, how to find eigenvalues and eigenvector of this matrix. So what is given to you, just write down. Given matrix A is equal to 1 2 4 3. Okay, what I have to do, have to find out trace of this matrix. So let us find the trace. Trace is what? Sum of diagonal element, this one. So 1 plus 3, that is how much? 4. Now let us find the determinant of this matrix. Determinant is how much? Determinant is 1 2 4 3. Okay, so this equal to what? Cross multiply. 3 minus 4 to the 8. 4 to the 8, so you will get what? Minus 5 as the determinant. Okay, so if determinant is non-zero, then what? Matrix A is what? Non-singular matrix. Okay, now what I have to do, have to find out the characteristic equation first. So therefore the characteristic equation is given by, the characteristic equation is given by what is that? A minus lambda I is equal to what? 0. This is the characteristic equation. Now write down your characteristic equation. So you will have 1 minus lambda. You have to subtract lambda by the diagonal element. So 1 minus lambda and 2 as it is 4 and 3 minus lambda. And this is what? Equal to 0. Okay. Now what I have to do? Have to write down the characteristic equation. So the characteristic equation is what? Characteristic equation for 2 cross 2 matrix is what? Lambda square minus trace of matrix A into lambda and plus, sign will be alternate, plus minus and plus. Plus is what? Determinant of matrix A, and this is equal to what? 0. So we write here lambda square minus trace of A is what? We found, that is 4 lambda, and determinant of A is how much? Minus 5. Just write down minus 5, and this equal to what? 0. And how to find roots of this equation? You know very well. You know very well how to find roots of equation. So 5. Take last term 5, and what are the possible divisor of 5? We can divide 5 by 1. Okay, we can divide 5 by 5. But what? Here we want 1. Sorry, here we want minus 4. So how will
So
get
minus 5
minus
plus
4?
1.
Yes,
Minus 5 plus 1.
yes, यहाँ पे minus 5 करेंगे तो आपको क्या मिलेगा? Minus 4. Okay, so just write down the two factor of this. So this is lambda. First one is, this is plus, write down plus, lambda plus 1 into lambda minus 4, lambda minus 5, this one, lambda minus 5, and this equal to what? 0. So you'll get lambda plus 1 equal to 0, or lambda minus 5 equal to 0. So from this you'll get lambda equal to minus 1, or lambda equal to what? plus 5. Okay, so these are the eigenvalues of the given matrix. Okay, which are eigenvalues of the given matrix. Okay, therefore lambda equal to -1 and 5 are eigenvalues of the matrix A. Okay, so this is what first part. Find the eigenvalues of the eigenvalues and eigenvector of the matrix. So by using eigenvalue of the matrix, we will determine eigenvector of the matrix. Okay, so let us find the eigenvector. Let us find the eigenvector. For this, we will move to the next page. Okay, now case number 1. Case number 1. If lambda 1 is equal to what? Lambda 1 equal to -1. Okay, then what happen? If lambda 1 equal to -1 is eigenvalue of the matrix A. Okay, so here we assume let x1 equal to, because this is the 2 cross 2 matrix, so your vector x1 has only 2 elements, so that is what, x1 and x2. Let x1 be the eigenvector, corresponding to the eigenvalue lambda 1 equal to -1. Okay, now since we know the formula, since a minus lambda I is equal to what? A minus lambda I into x is equal to what? 0. So this lambda replaced by lambda 1. So therefore this become a minus lambda 1 is -1 -1 I into x is equal to what? यहाँ पे आप क्या लिखना है? x1 लिखना है. x1 is equal to 0. So therefore we will have a minus good plus I and into x1 is equal to what? 0. But your a is what? Your a is just write on identity element. So your matrix A is what? 1, 2, 4, 3, and plus identity matrix 1, 0, 0, 1. Okay, and just put bracket, and x is what? Is x1, x2. Okay, and this equal to what? This is what vector. So here this is 0 is what? 0 is null vector. So just write down 0, 0. Okay, so all will be what? Matrix. So just 1 plus 1, you will 2, 2 or 0, 0, 4, 0, 4, 3, 1, that is what? 4. Getting? And write on the column vector
सर
x1. हाँ,
सर
and
2
this is,
प्लस 0 से 2 होएगा ना?
yes. So this is 1 and 1, 2, and 2 plus 0 is 2. Good. Yes, good. Thanks to remind. Okay. 1 plus 1, 2, and 2 plus 0, 2, and 4 plus 0, that is 4, and 3 plus 1, that is 4. Okay. Now what? What have to do? What have to do? So just reduce this element in row echelon form. Okay. So we will reduce this matrix in row echelon form. We write here
सर वो
R2.
आगे का 0 कॉलम नहीं लिखा, इक्वल टू 0
हाँ,
0.
yes, 0 0. ये तो आपको लिखना ही है. Okay, so we reduce this matrix in row echelon form. So we write here R2 minus 2 times of R1. Okay, so this is what, this is equivalent sign, tinda, इसको बोलते हैं tinda. Okay, this is equivalent sign. So this matrix is not equal to this matrix, so we will write just equivalent sign. Okay, so 2 and 2 as it is, because here right here R2 first, so R2 will change only. Okay, here R2 is first, so R2 only change. Okay, so 2 times of R1, that is what, here R2 is 4 and 2 times R1, that is 4. So 4 minus 4 0, and similarly here 4 minus 4 0. Okay, and write down the column vector x1 x2, and this is equal to what, 0 0. Okay, so just simplify this and find out the value of x and y. So we cross multiply, so we multiply here first row to first column, so this become what, 2x, okay, and plus 2x1 plus here 2 times of x2, and this equal to 0. Okay, so therefore we write here 2 times of x1 equal to, so this become minus 2 times of x2, and 2 will choose, so you'll get only x1 equal to minus of x2. Okay, x1 equal to minus of x2. So just replace x1 की value in this vector. So therefore we will have x1 is equal to, we found x1 value. X1 value is how much? Minus x2. Just write down minus x2, and x2 is what? X2 is x2 as it is, x2. So from this you will take common. What is the common? X2 is common. Just take outside. So you will get minus 1 1. Okay, minus 1 1. Where x2 is what? Where x2 is arbitrary. x2 is arbitrary. Arbitrary means what? If you take x2 is equal to 1, so you will get x1 is what? Minus 1 and 1. If you take x2 is 2, so you will get minus 2 and 2. If x2 is आपको 100 लेना है, so you will get minus 100 and 100. So if you change the value of x2, you will get different value, different vector x1. Getting? So therefore just take, in particular you should always take arbitrary vector as a 1, arbitrary element as a equal to 1. Okay, so you will have x1 is equal to minus 1 1 is an eigenvector, is an eigenvector corresponding to eigenvalue lambda equal to what? Minus 1. Okay. So this is the first eigenvector corresponding to the eigenvalue lambda equal to minus 1. Similarly, you will have the case 2. Then let us see the case 2. Case number 2. What is that case number 2? If lambda 2 is equal to how much? We found 5. Lambda 2 is 5. Okay. Now again we will have x2. Let x2 is equal to what? x1 and x2. Be an eigenvector corresponding to eigenvalue to the eigenvalue lambda 2 is equal to what? 5. Okay, lambda 2 equal to 5. Now since we know that formula, what is the formula? A minus lambda I into x is equal to 0. Okay, here lambda is what? Lambda 2, that is 5, and x will be what? x2. So therefore you will have a minus 5i x1, and this equal to 0. Now just find out matrix. So your A is what? your A is 1, 1, 2, 4, 3. Your A is 1, 2, 4, 3 minus 5. Minus 5. I is what? Identity matrix 1, 0, 0, 1. Okay. Just close in the bracket and write down column vector x1, x2, and this is what null matrix is what? Write down 0, 0. Getting? Null matrix is 0, 0. Just simplify. So you will get what? 5 minus 5. So 1 minus 5, that will be what? Minus 4. Okay. And 2 minus 0, that is what? 2. And 4 minus 0, that is 4. And 3 minus 5. How much?
Minus 2.
Yes, minus 2. Or you can directly subtract 5 on the diagonal element. Okay, you will get the same matrix. So into x1 x2. Okay, and this equal to your null vector, that is 0, 0. Again we will do the same thing. What I have to do here, we write here, see, second row we will make this second row will 0. Okay, so for this what I have to do, we just add, we adding r2 plus r1. Okay, this is equivalent sign, and we write first row as it is 4, 2. So adding 4 minus 4 or 4 minus 4, that is what? 0. Minus 2 and 2, that will what? 0. Okay, so this is into your column vector x1, x2, and this equal to 0, 0. Okay, so just multiply this first row to first column. So you will get second row and first column will 0. Okay, so you will have only one equation. Why this so? Because the rank of this matrix is what? Your rank of this matrix is 1, and number of n means number of variable is what? Your rank of matrix A is how much? 1, and your number of variable n is equal to how much? 2 hai. So you have the solution. Solution is what? N minus r. R means what? Your rank. So n will be what? N is 2, and r is what? 1. So you will get 1. So you will get one linearly independent solution. Okay. So these are the procedure to find out. So here rank of the matrix is A. Rank of the matrix is 1. Okay. So you'll get, just find out the equation. Just multiply it. So you'll have minus 4 x1 plus 2 times of x2, and this is equal to 0. Okay, so from this you will get x2 equal to 4 times of x2. So you will get 4 times of x1, 4 times of x1. So you'll get x2 is equal to 2 times of x1. Here you found value of x2. Okay, x2. So just replace the value of x2 by 2x. Okay, so this is x2, and this equal to what? Your x1. X1 is x1 as it is. You found x2 is what? X2 is 2 times of x1. 2 times of x1. Okay, so this equal to, I'm taking here x1 as outside, so this become 1 and 2. Okay, 1 2. Here we can write where x1 is an arbitrary x1 arbitrary. Okay, so for different value of x1 you will get different eigenvector. Okay, so just write down, therefore x2 is equal to 1 2, or you can say 1 comma 2, इसका ट्रांसपोज ले लो, is an eigenvector, is an eigenvector corresponding corresponding to eigenvalue lambda 2 is equal to what? 5. Okay, so in this way you can find eigenvalue and eigenvector of the given matrix. I hope you understood, students, how to find eigenvalues and eigenvector of the matrix.
सर वो आपने लिखा ना, जब ट्रांसपोर्ट किया 1 2 का, 1
हाँ,
सर 1, 2 लिखो सर, कॉमा रहेगा कि नहीं रहेगा एक्चुअली में?
देखो ये क्या वेक्टर के फॉर्म में लिख रहे हैं, तो आप कॉमा लगा सकते हो, ठीक है। ये वेक्टर
ओके
फॉर्म है, ये कॉलम मैट्रिक्स के फॉर्म में है, ठीक है। ये वेक्टर फॉर्म में है, वेक्टर फॉर्म में कॉलम, यहाँ पे कॉमा लगा सकते होगा। ये कैसे फाइंड करते हैं? आसान था, बोलो। इज दिस इजी फॉर यू?
हाँ सर।
यस
हाँ सर।
ठीक है, आई थिंक योर टाइम फिनिश, ओके, and we will meet soon in the next lecture. Thank you, Alaki, for joining to us. Now you can leave.